All right. Hello, everybody, and welcome to today's live session. Make Claude Code enterprise ready, the Tab 9 context engine, unlocking true organizational intelligence for autonomous agents. We're thrilled to have you join us today. As we give everybody a few minutes to settle in, I want to quickly go over a few housekeeping items. Today's session is being recorded, and we will share the recording with all registrants after the event, so don't worry. We also want this to be an interactive experience. As our speakers present, you will likely have questions about how these concepts apply to your own engineering environments. Please just submit your questions at any time using the chat feature on the screen. All right, let's get started. Over the past couple of years, we have all witnessed a rapid advancement in AI models. Agents are automating real engineering tasks, and the potential seems limitless. Yet, as many organizations are discovering, there is a hard truth here. Powerful models alone are simply not enough. Without a deep understanding of systems, architecture, and organizational constraints, AI can generate output, but it struggles to operate reliably in real-world, complex enterprise environments. Today, we're going to explore why context has become the critical missing layer in enterprise AI. We will discuss the challenges enterprises face when moving from experimentation to production, and why approaches that rely primarily on retrieving documents or fragments of code often fall short when relationships, dependencies, and constraints matter. To guide us through this discussion and introduce Tab 9's enterprise context engine, I'm joined by two leaders driving the vision here. Please welcome John Feeney, principal architect at Tab 9, who brings an extensive expertise in designing robust systems and architectures that enable AI to thrive in complex enterprise environments. And joining him is Avahai Libeskind-Mulyand, product manager at Tab 9, who is instrumental in shaping the product vision and ensuring our solutions meet the real-world needs of developers and organizations just like you guys. John, Avahai, thank you for being here. Avahai, I'll hand it over to you to kick things off.
Thanks, Lee. So hi, everyone. Welcome. Great to have you here. Today, we're going to talk about how to make Claude Code truly enterprise ready. We'll discuss how we can achieve this with the Tab 9 context engine, which really unlocks this organizational knowledge and context for the AI agents. Of course, this will enable AI agents such as Claude Code to perform much better in real-world enterprise scenarios and kind of move forward and towards working more and more autonomously. Later in the session, my colleague and friend John will walk you through some examples of some demo of how to actually work with Claude Code using the context engine. But before that, I want to kind of frame the problem and go over how we see things and why the context engine is the missing piece in this landscape. Okay, so when we talk about AI today, it's of course it's a field that's evolving really fast. The expectations are quite different than where we were 2 years ago, a year ago, or even a few months ago. So if we started in the notion that, hey, the AI can assist developers to work faster and be more productive by assisting them, maybe by being the chatbot that they can ask questions and get answer, or suggest some code suggestions, or maybe to assign small tasks to. Now, reality is that agents and AI is becoming more and more strong. It's able to really perform more complex tasks, wider tasks, and agent can plan their work. They can write the code, commit the code, write tests, run the test, validate the code. They can go until pushing the code and deploying it to production. So the capabilities are really increasing, and in this process, the human is less and less required. So we have this notion about human in the loop, right? The agent theoretically, not theoretically, the agent generates the code, and theoretically the human comes and review that, make sure that everything is fine. But as some of you who maybe tried a bit this tool, they become pretty cool. And if you work on, some personal projects, I know I have done, it's very, very over time you kind of trust these tools, and the human part is really diminishing. So we are moving fast towards more and more autonomous agent, and this raises a question or a challenge. Are enterprise ready for this shift? Are enterprise really can adopt this trend? Because the technology is moving fast, but adoption is more cautious. Think about it. It's like the question is, can organizations trust autonomous agents to actually manipulate production code, to go as far as deploying code fixes to production where the stakes are high? So, and for most organizations, the answer is still no, because to really move forward with this approach and hand over to autonomous agent more and more responsibility, there's a certain amount of trust which is required. And before the enterprise can delegate meaningful responsibilities to agents, they really need to have this trust. And if we think about what is really missing, the gap is mainly around the knowledge, really understanding the environment in which these agents perform in an organization. So the reality is that, yes, we know at this point that agents are really, really good at small projects, isolated projects, greenfield projects. They really achieve a significant amount of improvement. But when it comes to real world, complex enterprise environments, it fails. And it failed because enterprise environments are messy, right? They're complex. They have multiple services. They have sometimes multiple code bases. They have legacy layer, modern layer. They have complex architecture. They have different processes around CI/CD. They have knowledge which is scattered over an evolution over time, right? It can be some of this knowledge and the business logic can be implicit, that many of the humans are aware of, or it resides in many places, but not in a single one. And it's not really easy for the agents to understand the landscape in which they operate. The knowledge sometimes spread across, code, documentation, even some communication channels. So the problem really is that the AI simply does not know enough about your system to be able to take the right decisions alone, or even to know where it doesn't know the right context. So I'm sure those of you who work in organizations and experience how great these models and agents are probably can relate to what I'm saying. And this is, by the way, this is not anecdotal, right? There are some research that were done which describe exactly that. You have great gains when it comes to simple tasks, but when it comes to real world problem with different dependencies and different constraints, sometimes, not sometimes, often it's not as effective as productive. And in some cases, it can even be negative, because as a human, you in a place where you have to fix some of the things that the agent did, or if you have to kind of keep providing the relevant context, or fix the things that the agent is doing. By the way, another aspect of this is that unlike us humans, agents have no memory, right? So if there are different sessions of an agent that basically start by learning a little bit around the system that they're evolving in. It's they have to relearn this every time, right? This is not consistent. This is not something that's kind of, if I did it an hour ago, I remember it now. And of course, if you have multiple team members working on similar problems, every time the agent have to really learn it from the beginning. And the issue is that some relevant context cannot really be learned with few tokens and with a few minutes, right? Some of the deep relationship and understanding of an entire system really requires an exhaustive and wide search across multiple sources, which agents are, it's not feasible to kind of expect agents to do it, and they end up maybe find some of the relevant context, but it might not be always consistent. Maybe they randomly came across slightly different perspectives. Another way to think about it, by the way, is imagine that you hire the most brilliant and talented engineer to your team. How does this looks like on day one? Are you out of the door give him the keys to your production to start manipulating and changing it? No. Usually what happens, as smart as this person is, you'll probably do some onboarding. Some of the time in the beginning will be spent on learning really the system, the material, the architecture. And once he grabs some understanding of the domain, he can start being independent. And the most important thing that as time goes by, it's not like this engineer will know everything about the system. No, he will know the most data that he needs to know, and he will know what else, like the high level picture, and he will know, if he doesn't know, he will know where to get this additional context. And this is where really trust kicks in, right? When this developer in this case knows enough about what he can do and what he cannot do, and then gradually, while learning, it becomes something that's really this developer can do, can work independently and do bigger and bigger tasks. So in that respect, this day one of this brilliant developer this is where AI agents are now today. Okay, and the missing piece is this organizational knowledge, this learning process, this ability to kind of slowly but surely starting to get to know the system that they operate in. So the solution is then around defining or building the world agents operate in, where it's about making a unified and comprehensive view of the environment in which agents operate in, and to make them aware of how the system is built, what are the key components, how do they relate to each other, what kind of constraints are there, what's the requirements, what's maybe the regulations, what is maybe the history incidents that we have in similar cases. All of this is a knowledge that we're building, and basically is provided to the agents like a map to your organization. This map really represents the organizational knowledge. It's a high level view of the system. It has the key components and relationship, and it also hint where a more detailed data resides. So again, this is not about having every tiny detail in the context. Rather, it is more about having a bigger picture, kind of a way to have some orientation around the organization, and more importantly, know where we should go if you want to deep dive. It's like if you want to go from one city to another, right? You will use a map. You will see the big picture. You will see maybe I have to take this highway or that highway and take this exit and so on and so forth. I don't really need to know each and every street in the way. I don't really need to know each and every street in the destination or where I'm going from, because the agents are really good at it. If I can point the agent to a specific place where the more detailed context is, the agent can go and fetch this, and the agents are really good at that. So it's really about providing the agents with a way to make the right decision based on the right information, based on the right context, and thus making them more and more autonomous and arrive to a level in which we can trust them. So if you look at a modern stack of AI for the enterprise, it consists of three components. Obviously, the models, the LLMs, are the main feature that drive this. This is the intelligent, and we all know, we all experience this in our work life and in our personal life. These models become super strong, whether it's the leading model that are available through API, or even some of the models that are now available for self-host for organization. Then on top of that, we have the layer of agents. These are the application that are kind of wrapping and extracting the capabilities from the models while maintaining all kinds of features that allows us as humans to interact with them or to set them properly. And lastly, and this is what we're discussing today, is the context engine. Because when you work in a complex environment of an enterprise, you will need this if you want to be able to really be effective and find the right solution with adjusting to all the constraints. So we can look at this. A friend of mine in the company told me, hey, look, this is like the LLM is basically the agent, right? The agent, sorry, it's like the engine. The agent is like the car. You have small cars, you have big cars, you have fancy cars, you have all kinds of cars with all kinds of feature. And finally, the context engine is the map. Without the map, it's very difficult for you to navigate and to understand how you should go to wherever you want to go. So how the Tab9 context engine works. So basically, that's a kind of a recap of what we said. On the one hand, the Tab9 context engine is we're building a live organizational knowledge layer. We're basically taking information from all kind of data sources in the organization. It can be code, it can be documentation, it can be ticketing system, requirement system, regulation docs, whatever you can think of, and kind of maintaining it in a graph which really represent all the key entities in the organization, and more importantly, the relationship between them. So that's one aspect, building the knowledge, kind of maintaining it automatically. And the second thing, which is maybe not less important, is making this available for the agents, for any agent. It can be Claude Code, it can be the Tab9 agent, the Tab9 CLI, it can be Cursor, any other agent that's currently available or will be available in the future can access this data and query it very easily with a set of tools and skills. And this kind of complete the way that the agent can benefit from this context engine. And lastly, and before we move to John, I just want to recap some of the properties that are the Tab9 context engine has. So first, and I think we said it, it's multi-source ingestion. It's not just about picking the code base or the Jira tickets, each one of them separate. It's really about ingesting all of them and viewing them together, because everything is related. The second thing is that this is constantly being updated, right? It's configurable how often do we want it to be updated, but the data that the context engine, the way that we organize the world for the agents is relatively fresh, right? It's not something that's 2 months old. This is relevant. This maintains all the data, by the way, from structured sources and from unstructured sources, right? It's kind of combine everything together. Obviously, it's all built in an enterprise-grade security. It respects the existing permission structure. It's available also in self-host deployment, in air-gap deployment. And finally, and maybe one of the key features, it's customizable. So when we look at the landscape of an environment, there are quite a few entities and kind of relationship and sources that are very common. Every enterprise will have them, but every organization also have some unique things, unique elements or entities which are impacting or should be aware, the agent should be aware of. And this customization layer really helps us and helps you to kind of extend or adapt the context engine to kind of make sure it's optimized for your specific needs and your specific workflows. And this is, of course, very critical. Okay, with that note, I think, Lee, John, we can move to the demo.
Super, thanks, Avahai. So, hi everybody. So my job here now is to give you a live demo, show you something concrete regarding the Tabnine context engine. So this demo, I'm going to show you how the context engine solves one of the, arguably the biggest problem with AI coding tools today, and that is the number of correction cycles that are required with the AI generated code. So, you know, developers, they're pushing more code than ever before, faster than before, and there's a lot more to review in the code review stage. And very often, you know, some of that code gets rejected, right? We're using the wrong library, not following an accredited pattern, whatever it is, goes back to the developer. We go again, there are repeated cycles. And, you know, fundamentally, it's due to the fact that the AI coding tool doesn't have that institutional knowledge that it would need to generate correct code in the first place. So in this demo, I'm going to show you how we solve that with the Tabnine context engine. We're going to start with 2 separate Claude Code agents and sessions. One of them will have access to the Tabnine context engine, excuse me, and the other one will not. And they will both start from the same position. We'll provide them with a spec through a Jira ticket. So we'll see how they do with this task. And this is the Jira ticket here in question. So the work at hand here is we have an order submission service. And what we want to do, because customers have been charged multiple orders in the past, we want to introduce idempotency into the service. And so what's been asked of here, or what's been asked of the agents here, is the introduction of an idempotency key header. We want to avoid duplicate submissions, and we want to validate the keys on the server side. And what's driving all of this is a past incident, right? So this is the this is what we're going to give to the 2 instances of Claude Code. Now, a word about the code base where they'll be doing this work. So it's a mono repo written in Java, and in this mono repo there's a number of microservices. So each one of these is a Maven submodule. Now, the work that's going to be done will affect this order submission service here, and what you see is we've got 2 identical copies of this repo given to both of the Claude Code instances, exactly the same, apart from this Claude instruction file. And if I open this up and show you the differences here, there's nothing really majorly different between the 2, other than the fact that we're just saying to the Claude Code that has access to the context engine that the context engine is available to it through MCP. We're also telling it to obey the context that it receives from the context engine. We're also telling it to kind of just be very transparent about the work that it's doing. We're also, this is an important thing here, we're also saying we want it to cite its work. So where it's received artifacts from the context engine and has used those artifacts to generate code, we want it to cite those artifacts in the generated code. So this is just really useful from a demo point of view. And then on both sides, you have instructions on how to use GitLab to create a merge request. So nothing really crazy going on here. They're both very similar apart from the context engine piece. The other thing to really maybe point out is that I've created a hook on both sides where they will send their work or their activities into a web interface that I've created so that we can kind of see more easily what they're doing, and more on that in a moment. So these are mirrors of the repo, and what we'll do now is we'll have a look at the two Claude Code sessions. So on the left again, we have Claude Code without the context engine, and on the right we have Claude Code with access to the context engine. So we're going to give both of them the same instruction. And we'll fire off these tasks. And so we're telling both of them, first of all, ignore any memory. So we don't want them to cheat. And the prompt really simply is ship that Jira ticket as a production ready change in order for the order submission service, and then open an MR. Now, they're starting to work, and it's not really interesting to kind of watch a CLI or a terminal. And also, Claude Code isn't very, very transparent about what it's doing under the hood. So thanks to those hooks that I've created, we can go to a web interface here, and we can kind of see what they're doing. So here you can see in this very simple interface, on the left-hand side, again, is the Claude Code session without context engine. You can see that it has got the Jira ticket, and it's off to the races. It's exploring the local code base, trying to grab as much context locally as it can to try and fulfill this task. On the right-hand side, you can see that Tab9 or Claude Code with access to the context engine has got the ticket and has now made a call to the context engine. So it has determined that this is the file that we need to modify first and foremost, and it's now getting information about that file. And I'm going to show you now what kind of information is being provided to Claude Code here by the context engine. So we'll come back to this in a moment. So I'm going to switch now to the Tab9 context engine. Let's try that again. Okay, here we go. So this is the Tab9 context engine, and what you're looking at here is the knowledge graph. And if I'll just kind of zoom in here. So this is what we call the Graph Explorer. And what you're looking at here is the universe for this particular repo that we're working against. So we've got all of the services within the repo. We've got all of the past incidents, all of the ADRs, all of the tickets. We can see which teams own which service, and they're all connected to each other in a very complex web here. Now, these agents are now currently working on the order submission service. So let's zero in on that. So this is it here, the order submission service. And what I can do is I can cut out all of the rest of this noise. We can isolate this entity and all of its related entities. Okay. So in here, you know, when Claude Code calls the context engine and asks about that file that it wants to modify, it'll see that it's related to the order submission service, and that the order submission service has a number of SDLC artifacts attached to it. So we have a past incident that affected the service. You can see this relationship here. It affected the service. And also that incident led to the creation of this ADR here, this architectural decision record. And we have 3 ADRs in total that we really want to see included as context when Claude Code is generating code for this service. So the knowledge graph is a great way, and the context engine is a great way to bring all of this context from across your systems landscape, right? So very, very useful, especially where, you know, all of the entities are in different systems, and maybe they have very, very different data models. And, it would otherwise be very, very hard to connect these things together. The Tabnine context engine makes it very, very easy to bring these into the graph and to connect them together. And I can talk about that more later on. So what we'll do now is we'll have a look at some of these artifacts in more detail. So I'm going to go back here. We can see that both agents are still working away. I want to show you these artifacts in more detail. So I'm going to open up here this portal. And in here, that incident that I mentioned came from PagerDuty. So let's have a look at it in more detail. So what's happened here was there were 847 duplicate orders in the past, and that affected our customers. Here we have a full post-mortem, the root cause, and then crucially down here, the learning from all of this is that we should never use the Spring retry library, and instead we should use an internally developed library called CTX retry. So this is very, very important context that we want Claude Code to have, of course. And this incident led to the creation of this ADR that we saw in the graph. So let's go back and have a look at that in more detail. So these ADRs come from Confluence. And we can see in this ADR that this is the library, again, that we want to use. And there are guidelines on how to use this. So this library is stored in a private GitLab registry. And here's how we use it in our applications and all the details that an agent would need to do this properly. We have other ADRs in here as well. So again, a mention about that, a mention of that CTX retry library, but also when we're generating idempotency keys, they must be in UUID4 format. Actually, I'll make this a little bit bigger. Maybe you can't see this. And then also there's another guideline here around the database where the orders table must have a unique constraint. So again, this is important context, and we want to see all of this in the generated code. And then the last ADR specifies the exact key to be used when sending across idempotency HTTP headers. All right, so that's what's in the knowledge graph. That's what's been exposed to Claude Code, the one that's connected to the context engine. So let's now go back to...
Hey, John, I got a quick question maybe we could jump to real quick.
Yeah, go for it.
Yeah, so Satish is asking, I have legacy monolith code to refactor into modern microservices code. Do you have any best practices that can be used with Tabnine?
Yeah, so look, I would say when you're refactoring a large monolith into microservices code, I think you would just follow standard practices for that. But what I would say with respect to Tabnine, or indeed any other generative AI solution, do take consideration into the fact that these AI models are non-deterministic in some cases, and so you do want to be very clear about the language that you're using with these microservices, right? So if you can create documentation for these microservices that is really geared towards AI and models, be very clear and very precise about your language. That really helps a lot. Other than that, you can really migrate to a microservices architecture, and the Tabnine context engine provides ingesters to clone that repo, and then there are out of the box ingesters that will create those entities in the knowledge graph for you, or you can create your own if you want. It's a very simple prompt, because ultimately it's an agent that triggers an LLM. So you can very simply create a prompt to describe what your microservices architecture looks like, or what the repo is, how it's composed, and then what to look for within that repo. So a couple of things there.
Excellent. I'm going to throw one more up from Satish. I think it's possibly related. So how is the context engine constructed using Jira tickets, code base, ADRs, documents, etc.? Also, If there are inconsistencies between them, such as code changed but document not updated, how does the context engine handle that?
Yeah, that's a great question. So I actually can show this if I go to back to the context engine. So under so what I'm showing you is a very narrow view of the context engine. We're focusing very much on context today, but it offers a lot more capabilities such as agent orchestration. You can actually kick off most of your work as well inside the context engine itself, rather than through an AI coding tool, through things like work streams. But to answer the question, in the context engine, you can add a number of data sources from which the entities will be identified and inserted into the graph. You can see I have a few here, but we provide a number of out-of-the-box connectors for various sources of data and entities. So you can see that for version control systems, we have out-of-the-box connectors for GitHub, GitLab, Bitbucket, and so on. All of the popular issue tracking systems are in here as well, like Jira, documentation, communication platforms, and all of the various CI/CD systems like GitLab and Jenkins and so on. So these are all pre-built, and they know what to look for in your data sources. However, it's also very easy to create your own connectors as well in the context engine. At the end of the day, it's really an agent that runs powered by an LLM. So your custom connector or data source ingester could just be a very simple prompt, right? So it's quite easy and quite straightforward. And to the second part of the question, what happens if the original source of truth gets updated? Well, these data sources, they update in a variety of different ways. They can be configured to sync on a periodic basis, like through a cron schedule, or they can be updated through certain external events, right? So maybe a webhook from GitLab, when somebody pushes code or opens an issue, will fire a call into the context engine and trigger the data source to sync again, right? And you can always as well manually sync these data sources as well. So you have a few different avenues available to you there. Okay, so going back then to my two Claude Code sessions, they have both completed. If we have a look at the simplified web UI view, we can see, you'll see on the right-hand side that there were a number of calls made out to the context engine. This was one of the more crucial ones where we got all of that information about the file we wanted to update. A bit of semantic search happened here against the context engine as well, looking for software patterns for idempotency. And then at the very end, it created the MR and made a call to the context engine to get the team that belongs to the service that we updated. Okay, so both of these have completed. One thing you'll notice, I think we should see it in here. Yeah, you'll see that we can see all of the tasks that Claude Code created for itself. And on the right-hand side here, where we had access to the context engine, there are some very specific tasks created in line with what we saw in some of those ADRs, okay? So that's very pleasing to see. So the next thing to do is we'll go back to our two repos and we'll do a refresh and have a look at the differences as a result of those two runs. So we can see that the order submission service directory has changed, as we would expect. Expanding this, we can see the POM XML for a start has changed. So let's see what the difference is in here. Okay, and you can see the inclusion of that internal library that was mandated in this ADR 57, which is also cited in the POM XML. So that's nice to see. And we have nothing on the left-hand side here. So that's completely missing. And that's going to cause a problem in code review. If we go into the source then, and if we look first of all at the database side of things, there is a script here that's been created, and let's have a look. So we can see it's created an index, and it's also, this is the crucial one here, it has created that unique constraint on the orders table as outlined in the ADR, and that was mentioned in the incident as well. So you see both of those cited here at the top. So that's great. And if we look on the other side where we didn't use the context engine, let's make this a little bit bigger. There's an index that was created with no unique constraint. So that's completely missing on this side as well. Now, if we go into the source code, and I'll just pick out a couple of examples here. So there's the creation of a new idempotency folder on this side here. So again, on the right-hand side is where we had access to the context engine. And let's have a look and see. Again, ADR 47 is mentioned, and this is the UUID v4 pattern, which has been adhered to on this side here, which is great. What else do we have here? We have the order class, and making this a little bit bigger again. Okay, so here's a big glaring difference. So on the left-hand side, we don't have, so on the right-hand side here, you can see we have that unique equal to true, which marries with what we did in the database. And again, we've cited the ADR from which this this inspiration came from, right? So, and that's missing on the left-hand side. And so you get the idea here. We're going through these we're going through the code here, and we're seeing a pattern emerging. Without the sufficient context on the left-hand side, we're generating code that is syntactically correct, but ultimately is going to get rejected at review time. And this is going to result in those correction cycles where we need to do repeated prompting and numerous iterations, a lot of pain. But here with the context engine, we're generating the right code the first time. So here is ADR 4, which was the other ADR that we saw. And yeah, it's looking good on this side as well. All right. So the code on the right, I'm confident will pass through code review without any issue whatsoever. So what we're going to do now is we're going to have a look at the merge requests that were created by both agents. So if we go back to the agent output, we can see at the very end here, on this side here where we had the context engine, we have an MR that was created for us. So let's copy that URL. And let's open that up and have a look at what's inside this MR. Okay, so the first thing I want to point out to you here, which is really nice to see, is that we have some more information in here that came from the context engine, and that is the reviewer. So Claude Code was able to see from the context engine who owns the service. It saw that Joe was a code owner for the service, and so added him as a reviewer. And also, it saw that the order platform team owns that service, and so it's applied the correct label here in this case. Also, in the MR, it's given us, quite extensive, an extensive audit trail where all of this code originated from that it has generated. So everything that's in line with these directives within our architectural documents. So that's really, really, really the kind of thing that you want to see. And let's compare that then to the MR that was created by Claude Code, and where it was lacking that level of context. So going back here, we'll open up a new tab, paste in. Okay, so first thing to see is that we have no reviewer assigned to this MR because it doesn't know who owned the service, right? And also it's made a best effort guess at what the label should be here. So that's incorrect. And on the surface this might look correct, but you can see that we're missing all of the references to our SDLC artifacts. So again, if I go back to here, just to wrap up, what we're seeing here is the importance of context. That we all know that context is important with AI, but you've seen here that with the Tabnine context engine, we can really help these agents and these coding tools to generate the right code the first time. And so, the question that you all need to ask yourself when you're evaluating your current tools or new tooling is not, can it code? Because the answer to that is yes, they can all code. That's a given. But the question is, can it code correctly, right? As in, can it code in line with our ways of working, our patterns, our architecture, and our history, right? And so hopefully, you've got a sense of what is possible here with the Tabnine context engine. And I would encourage you, when you're evaluating your tools, if you find that, there is something that can be improved there, do give us a shout. We'd love to talk to you and see how we can help. Okay, Lee, that brings me to a conclusion there.
Excellent. Cool. So let's hop over to a couple questions that we have in the chat. So first off, are the entities in the graph, like the ADR documents, for example, exact copies of the source material from other systems? The concern here is that we might be creating multiple sources of truth.
Yeah, that's a great question, and it kind of overlaps a little bit with the earlier question that we had. So you've got a couple of approaches here. I think the guiding principle with the Tabnine context engine is, yes, we will ingest these entities, and we'll store them in the graph. Now, the intention here is we won't store exact copies of the original source material in the graph, but rather the model will summarize what the contents of that entity. But the guiding principle is that we'll have the summary of that context entity and also a URL where the agent can retrieve the entire artifact in its fully. So it really depends on your use case, because for the most part, the summarized version of these entities or artifacts is sufficient for the agent to be able to accomplish its task. However, you may decide that you want to actually pull the entire document, and if you do, it's a very simple instruction in your Claude MD file to say, right, listen, when you get context from the context engine, I also want you to use that URL to go to the authoritative source and grab the entire document. So I want all of that in the context window. So they're not replicas of the original source material. And the other part of the question is, if there is an update to the source material, as I mentioned before, the data sources can automatically sync when that happens. And so the entities in the graph will be updated accordingly.
Excellent. So a couple more here. I want to drop through these quickly. Can you explain how the context engine can be used to reduce token consumption?
Yeah. So, as Avahai mentioned, the context engine can certainly be used to reduce token consumption. It really depends. If that is what your objective is, there's a lot of kind of like it depends to answer that question. So it really depends on what data you've got in the graph, right? It depends as well what's in your prompt, and it depends really what your objective is. So I think for most organizations, really what's most important is getting as much context as possible, which would result in more tokens, right, and more consumption of tokens. However, if your goal is really the reduction of token consumption, then you could certainly structure your graph in a way that facilitates that. And then in your prompt and in the Claude MD instruction file, you can tell your client, to kind of discover items through the context engine rather than exploring the code base extensively, right? So it really depends. It depends on what your exact objective is, what the prompt is, what's in the graph. But certainly, yes, you can. I would say the most common path really is people do want to kind of pull in as much context as possible, because as you saw in the demo, the more relevant context you have, the more accurate the output's going to be.
Excellent. Got a question here from Pablo. So how do you manage the deduping? The graph pipeline has any human in the loop endpoint?
Yeah, so the deduping is done through what's called upserting into the graph. So where these entities already exist, and they're not going to be overwritten, but what you might end up updating is maybe there's a new another entity that's entering the graph that has a relationship already to the existing entity, and so that relationship will be created. So it's, and again, if you want that behavior, that's the default behavior. But if you do want to modify that, it's a simple prompt to an LLM. So the system is clever enough to know, yeah, we're ingesting this data again. We already have that entity. We don't need to recreate that, but we may want to create a new relationship to another entity. And is there any human in the loop endpoint? No, there isn't. But there can be if you want there to be.
Excellent, Strop. Satish has another one. Can I use the context engine to debug some very tricky performance or resilience issues at production? And what context would be most relevant?
Yeah, absolutely. That's a great use case for the context engine. So as I mentioned before, when I showed the graph, putting all of this context into the knowledge graph is especially useful where the data is coming from different systems and different data models. So if you're using New Relic, Datadog, Dynatrace, there's so much rich context in those systems that you will want to connect back to your code base. And so that's a classic use case for the context engine, where maybe you'll have an MCP tool that talks to New Relic, for example, if that's your APM, where it establishes, okay, we've got some outlier in performance, and then you can make a call to the context engine to say, okay, I'm seeing this in New Relic, right? I want you to help me connect the dots in my application code and across my application landscape to see what the root cause might be. So yeah, and what context would be most relevant in your question, Satish? I would say as much context as possible. Put everything in there, and the context engine will do the rest of the work.
Excellent. A couple more here. Let's see if we can get these done. What's the difference between the context engine and simply using MCP to grab various sources of context as needed for a project?
Yeah, that's a common question, and it's reasonable and intuitive to ask that. I think when it comes to building a view of the world yourself and building your own MCP connections, that's kind of easy to do in some cases and not so easy to do in others. So for example, if you're using GitHub and you're using the full breadth of that platform, so you're using GitHub issues, you're storing your code in GitHub, you're using GitHub Actions for your CI/CD, there are a lot of native integrations in there, so it's very easy to go from the PR to a commit and then to the actual code. And you can get a lot of that context very quickly through a single MCP server or very few MCP tools. However, as I mentioned before, where the data resides across the system boundaries and across different data models, like you've got data in ServiceNow, PagerDuty, in Confluence, in Jenkins, it becomes a lot harder to connect these things together without an awful lot of work and in a very kind of a cohesive way. And that's what this platform has been built for, is to really bring together all of those data points from across your heterogeneous landscape. That's really hard to do with manual context assembly. It can be an awful lot of effort.
Great answer. We got time for one more.
Yep.
What data sources can we connect to the context engine?
Well, as I showed earlier on in the, I think I brought it up in the dialogue. I should bring it up again. I think. Let's go back here. Here we go. You've got all the major source control systems: GitHub, GitLab, Bitbucket, and so on. You've got Jira, Zendesk, Monday. This is the out of the box stuff. You can create your own. There are templates that you can follow. It's really easy. You've got Confluence, Notion, Slack, and then all of the various CI/CD systems. So basically, all of the major systems that you can think of that would support your application and software delivery efforts, they can be used as data sources. And then if we don't have an out-of-the-box ingester to pull in meaningful entities from those data sources, or if there's something bespoke that you need to cater for, you can create your own ingesters, and it's really the simplest of these ingesters would be just like a single prompt that tells the LLM what to look for. All right, so the world is your oyster here.
Fantastic. All right, that was perfect. It looks like we're just about out of time here. I want to give a huge thank you to everyone who joined us today. The level of engagement and the quality of questions we received today have been fantastic. If we didn't get to your specific question during the Q&A, please know that our team has captured it and we'll be following up with you directly via email. John, Avahai, thank you so much for both sharing your invaluable insights today. It's clear that as AI moves from pilot to production, having that deep, persistent understanding of the organizational systems and constraints is no longer just a nice to have. It really is a critical foundation for operational safety at scale. For those listening who are dealing with these exact challenges, navigating complex architectures, managing dependencies, and trying to make AI work reliably within your specific organizational constraints, we would love to show you what it looks like in practice. We invite you to connect with our team for a personalized one-to-one demo. We can walk you through your specific environments and show you exactly how Tabnine Enterprise Context Engine can map your systems and empower your AI agents to reason and operate safely within your unique infrastructure. So, as you'll see a link showing up in just a second on your screen, you can book a session, and you can always reach out to us directly at context.tabnine.com. Thank you again for your time, your questions, and your participation today. Have a great rest of your day, and we look forward to speaking with you soon.